So in this class, we're going to talk about big data and how big data analytics are used to make intelligent decisions and how we use these technological tools. So let's start off with some interesting facts about big data. Here's one. If you stacked a pile of CD-ROMs, remember those, right, on top of one another until you reach the global capacity for the storage of digital information, which is estimated at 296 exabytes, well, it would stretch 80,000 kilometers beyond the moon. Lots and lots of digital storage capacity or digital information out there. Here's another fact. Every hour, enough information is consumed via internet traffic to fill 7 million DVDs. Every hour. And that's increased. I mean, this data this is survey data, and it increases every day. So here's another fact. And side by side, that data is enough to scale Mount Everest 95 times. Pretty amazing. Here's another statistic. Of the world's 500,000 plus data centers, it's large enough to fill 5,955 football fields. Lots and lots of storage for that data. Here's another statistic. The big data market is set to increase from 3.2 billion USD, United States dollars, to 16.9 billion by the year 2015. Yet another fact. And by 2020, a third of all this data will be stored in the cloud or have passed through our understanding, what we call the cloud. And will have created, I don't even know how to say that number, a lot, a lot of bytes of data. I don't know. It's trillion, I have no idea. It's huge amounts of data. So when we say big data, what we're really talking about is the ability to analyze massive amounts of data using sophisticated algorithms. And we'll talk a little bit about these sophisticated algorithms, but we're going to mainly talk about what big data is and kind of the impacts it has. So what we call this is advanced analytics when we use these algorithms to analyze data. And so let's take a look at some of these sophisticated analytics. Just a high overview. I mean, that's for the math and computer science people to really delve down and understand the nature of these algorithms so that they can be matured. But we're just going to take a look at their practical use. So there's conventional predictive modeling, which is the process by which a model is created or chosen to try to best predict the probability of an outcome. There's this notion of neural networks, which are just computational models that are inspired by an animal's central nervous systems, our brains. And then there's social network mapping, which has been around for quite a while in algorithmic form, but is now used quite frequently in technology. It's actually been around since the 60s. It views social relationships in terms of network theory, which consists of nodes, which represent individual actors in the network, and ties, which represent relationships, such as between individuals, such as friendship, kinship, organization, sexual relationships, etc. And then there's the visualization tools, which help render these analytics and make them comprehensible by you and me. So this results in tremendous opportunities for us, and tremendous things you have to watch out for. It creates a lot of transparency because you now have tons and tons of data that you can make sense of in ways we've never been able to make sense of it before. It also enables new kind of experiments. Science is changing because of big data. New science fields are cropping up because of big data. Decision sciences, which didn't have much of a following for many years, is starting to have a little bit more of a following now because people in the decision sciences realm are becoming big data experts. And this is also happening in information systems too. It allows us to segment populations in ways we never deemed possible. It gives us new types of decision-making tools and helps us create new types of business models, products, and services. So that was really generic. Let's give you an example. So, for example, a direct mailing campaign, right, where I'm a store owner and I want to send via snail mail some sort of notification about sales I'm having, something that'll get you into the store so that you can buy product. So traditionally, this would be a direct mailing based on very generic segmentation. That person's coming to your store and they've entered in a little bit of information. You might know whether they're married or single, where they live, and the things that they've purchased. Very basic information like that. So from this, you can run a regression. You can do very basic predictive modeling based on what you think are their preferences, and you can send essentially the same information to all customers with a little bit of deviation, but very little. But with analytics, you can look at it from another view. You can look at it from something like customer value modeling, where you can model what you're doing for customers based on what you can be doing, and you can segment in different ways. Whereas in the top picture you have a single segment that basically incorporates all the other segments, and you're basically sending out one generic thing. In the lower model, you've captured these segments. You have their information. You know where they live, so you can send them a direct mail based on these sentiments and preferences, as opposed to the generic ones, or the ones that are blanketed across your entire populace of former customers and hopefully future customers. So it allows you to target these segments and dissect a customer base in a way that you've never been able to do it before. So here's another example. This is more predictive. What do we think is the next product a customer will actually buy? So you're in this big business, Walmart, for example, and you have 80 million customers and 100 million transactions. And that, in the picture I have there, is just a bunch of data that you're not able to make much sense of. But with stuff like multivariate statistics and association rule analysis, and of course the fact that what we've been talking about all semester is that compute power and the ability to process it is becoming cheaper and cheaper every day, and has certainly reached a critical mass where even small businesses can do this type of stuff. You have the trifecta of things that allow you to actually analyze data and do things like association rule analysis, which identifies strong rules discovered in databases using different measures of interestingness, right? Regularities between products in a large-scale transaction. You have data recorded by point-of-sale systems in supermarkets. For example, you can incorporate a rule such as when someone buys onions and potatoes, then they're also likely to buy a burger. This rule was found in the sales data of a large supermarket, and can actually indicate if a customer buys onion and potatoes, then he or she is actually likely to buy hamburger meat. So you've got a lot of opportunity there of how to market, onions, potatoes, and hamburger meat all together, or to offer some at retail and a discount on others. So let's move on to the next slide. With this big data analysis, with these advanced analytics, you can segment between infrequent shoppers, frequent shoppers, or people who just like to visit your website, right? So you might want, for infrequent shoppers, you might want to do something like offer them the most probable recommendation that they're that's potentially likely to get them to come into the store again. For frequent shoppers, you want to do something different. You want to get recommendations to generate the maximum margin, because you're sure they're going to come in, but you want to get the biggest profit margin. So you would engineer the type of marketing that you would do for when they do come into the store, not if. And then for site lovers, this is where you're trying to get them in. So you receive recommendations from other categories to broaden their purchase behavior. Okay, so how big of a deal is big data? Well, If you do a search on Google Trends, I don't know if you knew about this, but if you didn't, I put the link there at the bottom of the presentation. If you knew about Google Trends, it shows that since 2011, the number of queries and interest over the term big data has just skyrocketed. And then what's also interesting is you can break it down by region, and you can see where the multitudes of people are actually searching for this term. So what's really interesting is India tops the list. The U.S. comes in what, 6th, 7th there. South Korea is 2nd, Singapore, Taiwan, Hong Kong, and then below the United States is Israel. So it's interesting how it's split up by geographic region. I would have thought that maybe Europe and the United States would have been higher, but as you can see, Europe's not even on the chart. So who knows why that is? But what it does tell us is that big data is a big deal. So here's also, going to the next slide, a report on big data from McKinsey. This is there's other organizations that do reports on business and surveys on businesses and what's hot and what's not. Gartner, Forrester, McKinsey's another one. And so what they say in the report is that data has swept into every industry and business function and are now an important factor of production, alongside labor and capital. Data, imagine this. Let's stop right there. Data as an important factor of production right there with labor and capital. That's amazing. So we estimate that by 2009, nearly all sectors in the U.S. economy had at least an average of 200 terabytes of stored data, twice the size of U.S. retailer Walmart's data warehouse back in the late 90s. That's amazing. So then these are looking at companies with more than 1,000 employees. So the other things they say is that the use of big data will become a key basis of competition and growth for individual firms. Because to be competitive in our data-driven economy, you're going to need to target, market, and segment, and target your current, potential, and future customers, like you never have before. And so what's also interesting here, and this is food for thought for you folks, is that there will be a shortage of talent necessary for organizations to take advantage of big data. And by 2018, just a mere 4 years from now, the United States alone could face a shortage of 140,000 to 190,000 people with deep analytical skills, as well as 1.5 million managers and analysts with the know-how to use the analysis of big data to make effective decisions. So coming to a San Francisco State near you is probably going to be a master's in analytics. There's been a lot of talk about it between my department, computer science, and decision sciences, and even the math department. So this I can pretty much guarantee is going to be coming to a San Francisco State near you at some point in the near future. And a lot of universities are also offering these types of specialized masters in business administration. So it's not about knowing the algorithms. It's knowing how to use the tools that have the algorithms and how to make sense of their decision, of the criteria that it gives you to make decisions. So let's move on to the next slide. So emerging opportunities for big data. Well, one is smart cities, where 50% of the world's population actually lives in what we qualify as a city. We live in a very dense city, one of the densest in the world, where you have lots and lots of statistics like census, crime, emergency visits, taxis, public transportation, real estate, noise, energy. And these are great determinants for people to figure out where they want to live in the city, whether or not they want to live in a city. And so interestingly, cities are making their data available. You can go to data.gov and look at data sites for different cities. Or there's the NYC, New York City Open Data Initiative that's also available you could take a look at. So collectively, this makes cities more efficient and sustainable and improves the lives of its citizens because it helps citizens make decisions like they've never made before. How nice would it be to know all of that data listed above before you moved into a particular neighborhood? That would be great. So let's move on to the next slide and talk a little bit about the market for data. Consider data currency, right? Data is currency, and companies are profiting from knowledge that are extracted from big data or advanced analytics. So data equals money, right? Many of the major startups right here in San Francisco are more interested in getting your data than your money. And so you just have to realize that if you're not paying for a service such as Gmail, Facebook, Twitter, Instagram, Airbnb, maybe, uh, you know, then you are their product. You are the product that they are selling, right? Your information and the ability to have the analysis for companies like Facebook to analyze it, and then people use their advertising platforms and they connect buyers and storefronts, and potential customers, or suppliers and potential customers, is invaluable. And so, companies like Facebook and Google, they make their money off advertising, and that's a little bit of a breakdown of how they do it. So this is not new, going to the next slide. Financial transactions, call detail, records, astronomy, scientific data sets, all require massive amounts of data to be processed for analysis. Data centers, when I lived in San Diego, there was a UC San Diego Center for Supercomputing, where it was basically giant racks of servers that were doing, millions and millions of petaflops of transactions, so that scientists could run their experiments in ways they've never done before. Coincidentally, the San Diego Center for Supercomputing is changing drastically, because now you can use cloud computing to do a lot of that stuff, and it's a lot cheaper than the facilities they have at UCSD. But still, many of them actually still use it, because they have their experiments there, they know it, and they're familiar with it, and it's potentially maybe even cheaper, because it's probably free if you're part of the university. But the way that science is doing large-scale experiments that require massive amounts of processing, where it used to be something where universities were working strictly with other universities for the ability to process this data, is changing drastically. And so data, in addition, is now more widely available than it ever has been, especially when folks like you and me are using all those free services and getting access to those world-class applications for nothing other than giving our data away, and the sediments that we elicit, that we exude as we go and click and like things, and add hashtags to pictures and things like that. And increasingly, compute power is cheap and easy to access. So there's a lot of things that are difficult with big data, right? The scalability of computations or algorithms. We think that's difficult? No, actually that's not. There's a lot of work on distributed systems and parallel databases, and there's lots and lots of elasticity, especially when you're talking about cloud computing with respect to adding more computing power. But there's no one-size-fits-all solution, and that's what makes things really difficult. It's kind of like the analogy that I gave at the beginning of the semester, where there's bricks and then there's grass between the bricks, and the bricks are representative of the technology, and then the grass that grows between them, which is inevitable, is human behavior. And it doesn't matter how you place the bricks, try to exterminate human behavior. Well, that sounds terrible, but try and minimize human behavior. It doesn't matter. The grass will still continue to grow, and grow in new places and new ways that you didn't imagine. So nature always wins, right? And that's kind of the thing with human behavior as representative of nature, right? So there's no one-size-fits-all solution. You have to know your data to be able to build your own advanced analytics. And with rapidly evolving technology and many different tools, this is difficult. Another element about this is the ethics around big data. Should you be analyzing all of this stuff? What kind of correlations should you be making? Are we making too many correlations? Are we trying to find out too much? Are we trying to find out things that just might not be true? Who knows? So there's a lot of ethics, and I don't talk much about it in this presentation, but that's another thing that's difficult about big data. So moving on, I get a little bit with what's so difficult. Scalability for people, right? How do you make data exploration easier? And then how do you make it easier to turn data into knowledge, right? When you talk about all those different algorithms, how do you actually take this stuff that comes out of all this data that you've put in, how do you turn it into something that's usable for people to help them make decisions, with respect to targeted marketing campaigns, or any other type of thing that will help you get more customers or people to use your service. So let's move on to the next slide and talk about the big data analysis pipeline. So there's a lot of things that go into being able to do these types of analytics. And so, the major steps are on top, and the steps on the bottom are the data needs that make the task challenging. And I know they might be a little bit difficult to see, but, it comes down to recording the data, cleaning it, integrating or aggregating it, and then analyzing and modeling that data. And then the last thing, which is the most human intensive, is the interpretation. And so, the things that are challenging, the big data needs that are on the bottom are, heterogeneity of data, the scale of it, and the privacy of it, and the way that humans collaborate on it. These are all things that make that make the task of advanced analytics quite challenging. So let's talk a little bit about big data technologies. And so, we've talked about this throughout the semester, so I don't spend a lot of time here. This is not where we spend a lot of time. We've talked about the cloud. We've talked about NoSQL and things like that. So what adds to the discussion on big data are technologies like Hadoop, which is open source, which allows you to do MapReduce, which I think I've talked a little bit about in some earlier lectures, which is an algorithm that was first published by Google that a lot of people have taken, which allows you to make associations and then condense your data based on those associations. So I don't know if that makes sense, but the ability to associate something, based on some sort of algorithm. I want to associate picture frames with pictures. So I can try and make a determination as to whether or not what pictures look good in what picture frames. And then when I can take millions and millions of associations and then reduce them based on correlations, or based on relations that I found within those associations, I then have a much more compact set of data that I can then go analyze. And so there's a lot of mechanics behind MapReduce. If you're ever interested, I would suggest you actually try and pick up the paper from, I think it was maybe the early 2000s, that came out of Google Labs, that's widely available. You can just look up Google and MapReduce and you'll find the paper, I think on research.google.com. And try and make your way through it and understand what it's talking about. It's a really interesting paper, but it is quite complex. I actually need to sit down and really read and think about it when I've read it. I've read it several times, as it's been critical to my work and my research alike. So anyways, that's kind of an overview of the technology, which is much of what we talked about before. But then there's also different types of query languages that I discussed here, JQL, Pig Latin, JavaScript, if you're using MongoDB, I know it's NoSQL database, you're using JavaScript to develop queries. There's other types of languages and things like that are more centric to big data and increasingly being used in an advanced analytics environment. So why data analytics, right? I mean, it gives us the ability to, like this little cute cartoon, says it gives you the ability to do prediction in ways we've never done it before. So who are our highest or lowest margin customers? Who helps us make the most profit? Who's not really giving us much return? Who are my customers? What products are they buying? Which customers are most likely to go to the competition or switch? What impact will new products and services have on revenue and margins? What product promotions have the biggest impact on revenue? And what is the most effective distribution channel to be able to circulate these products? So these are a lot of the questions that we can answer with big data, with advanced analytics. Some other ones, what is the destination of thrift lanes? Where should drivers go to get passengers? What impact will the introduction of additional medallions have, for example? Very central to the cartoon, I suppose. What is the quickest route from Midtown to downtown at 4 p.m. on Monday? What would be the impacts of a fare change, as it relates to public transportation? So that gives you also some intimation that big data is being used in government. Especially with regard to municipalities in a place as complex as San Francisco with respect to public transportation. How do you get more reliable transportation to people? So I gave a 50,000 foot overview of big data. There's a lot of complexities I didn't cover, but rather I wanted to focus on the importance and difficulties of the issues around big data. So we focused on the stuff that used, to be hard but is now easy, such as cost and accessibility of computing power, and applications to process your data. So when you have so much compute power and software availability, you can process anything. But the real question is, should you? What should you be processing? Are we looking at too much? Maybe if we work in an area where we have a lot of sensitive information about people, like a pharmacy, for example. What type of data should you be analyzing, and what should you be leaving alone? Right. So there's a big ethics question around big data, and there's articles every day about that. So this is just something to think about, and I hope what this presentation did was help you understand a little bit about the importance of what's going on in our society today with this thing we call big data, and what you're likely to see in one form or another in your lives if you don't already, if you haven't already intellectualized what you've experienced with respect to the services you use every day for social media and e-commerce. So until next time, we're getting close to the semester, and I hope you've enjoyed that so far, and I hope you enjoyed this presentation. See you soon.